Hi, everyone, and welcome to Cloud Foundry Summit 2020. And more importantly, welcome to Cloud Foundry for K8s. It's the same great platform as a service on a brand new foundation. I'm Andrew Wittrock, member of technical staff at VMware, and joining me is Eric Promislow, senior developer at SUSE. We are both members of the release integration team, responsible for integrating the open source Cloud Foundry releases into both the BOSH-based CF deployment, as well as the Kubernetes-based CF for K8s. So, what is CF for K8s? CF for K8s is Cloud Foundry on K8s. Cloud Foundry is an open source multi-cloud application platform as a service governed by the Cloud Foundry Foundation. So CF for K8s is putting Cloud Foundry on Kubernetes. It reinvents the platform as a native Kubernetes application platform for deploying, running, and managing other applications. We're using the best parts of Cloud Foundry and integrating them into Kubernetes. We run CF components as OCI-compliant image containers in Kubernetes instead of separate VMs as you would see in BOSH. We package and deploy these developer applications, and the CF haiku still definitely applies. You can deploy your applications without the how. You don't have to care about that. It should be very familiar to our current Cloud Foundry users. Why CF for K8s? So CF for K8s is a brand new re-envisioning on the current platforms of the web. It deploys much faster, less than 1/5 of the deploy time of a similar BOSH deployment. You can bring your own IaaS, so whatever cluster you want to use, you can drop CF for K8s on as a platform that works on any of the Kubernetes IaaS. Provisioning tools like Terraform have more libraries and tools for targeting Kubernetes, so there's less need for a specialized tool, say like Bubble. As the industry is advanced, there comes a time when there are advantages to moving to the dominant paradigm, and moving to Kubernetes allows us to leverage community-produced components. So at this point, I'm going to turn it over to Eric so he can provide a short demo.
Thanks, Andrew. Whoops. We initially wanted to give a demo to show how you can go from like 0 to 60 from just a bare bones Kubernetes cluster to a ready to run Cloud Foundry. But it takes about 10 minutes. That's a lot faster than the 50 minutes or hour it would in the BOSH CF deployment world. But it's still more than we wanted at a talk today. But what we're going to show is when you're at 60, what's life like in the passing lane? And we're going to just make a modification. So let's just go to this screen and I'll show you our components. What you need is obviously a cluster on some IaaS, or you can possibly even try Minikube if your machine has enough juice. On this particular cluster, we're running 5 nodes. The nodes are in the Google world N1 standard 4. It's possible to use N1 standard 2. Up to you, depending what you want to do. And we have network policy enabled. So if you're going in that world, you know what I mean there. We also need a service account. We're using this one here. And we save a key. Under here, you could create a key. I already have a key on my machine. It's got that ID 1581, and I'll be using that. I need that to get permission to access the container registry. If you need to modify it as well, you'll need the IAM tab. So these are the 3 tabs in the Google world you'll need. You'll also need to know what your DNS names are as well, and I'll show that later as well. So what it looks like over here, so I am running an existing Cloud Foundry system right here. I'm just asking what are all the pods that are in the CF system namespace. In particular, we're running 2 API servers. What I'd like to show you is what it takes to move to 3 API servers in this world. There is a file. Let me just work here. I'll be talking more about what's going on. There's some terminology and technology here. This is the Cloud Foundry Cloud Controller deployment file. So it is a standard Kubernetes deployment object, which means it can do blue-green deployment, and currently it comes with 2 replicas. We'd like to change it to 3. You might be tempted to change this 2 to 3 and go with that, and you would be correct, but if a new version of CAPI ships and you pull it in, you will lose your setting of replicas from switching to 2 to 3. So instead, we're going to be using YTT, which is this variant of YAML. You might already have noticed that there's some things that look very un-YAML-like. Whoops. Here, for example, this hash at load YTT data at line 1, that's a YTT directive. YTT is the YAML template toolkit. Like it sounds, it's a templating tool. We're going to use, and it's used to help us manage the huge amount of Kubernetes that is otherwise required to deploy Cloud Foundry onto Kubernetes. We're going to use this config file. It's kind of like an ops file in the CF deployment world. And the key is here, we want to change replicas to 3. We're now saying find an existing object that is a deployment object, and its name is CF API server, and find the spec field in there and look for this line that matches and change the setting for replicas from whatever it is to 3. And if it's the match missing OK equals true, means if it's not there, let's add it. Because by default, the replicas count is 1. That's all we need to do the change. There's a little bit of setup as well, and it's not too different from actually doing an initial deployment. So we need to define some variables first, and I'm going to use them to work with the cluster. Also, I like using shell variables so I can refer to them. Just like I don't like repeating myself in code, I don't like repeating myself on command lines too much either, and YTT is very much part of that dry, do not repeat yourself philosophy of working with software. So like our full domain, cfsummit2020.k8sdev.relent.rocks, we'll be doing the API to connect to that. Now, what we have in the config directory is just a big generic Cloud Foundry deployment, but we need to add some specifications to it to make it our own. And we're going to put those specifications in a values file, and that will be the name of it, and I'll just put it over in temp. And then remember, I talked about the service keys. Well, when you create a key in Google Cloud and save it, it just saves it to your JSON file. So there's the one with that ID 15818, etc. Okay, now it's time to make populate the values file. We have this hack directory with some helper scripts. They are all intended to be temporary until we figure out a better way to do this. And there is a sample values file in the repository as well that you can use to customize yourself if you prefer, but I'm going to use this tool. I just need to give it 2 parameters. I need to give it the full domain, that's the -d flag, and I need to give it the service key, and I'm going to write it out to the values file. The greater than bar is there because I have no clobber set. So what's in the values file? I have a tool to display it. And you can see some familiar things like system domain is cfsummit2020.k8sdev, like I said. We also are using the Bosch CLI or Bosch CLI technology to generate a lot of the certs and passwords we don't care about. We just want them to be long enough that they're secure and that the certs and keys conform to SSL. So you can see, yes, we have passwords, we have certs, we have specs. Down at the bottom, we have basically, this is an encoded form of our service key that we got from Google Cloud. So we'll be able to use this to access the container registry. So that's there. The next step is, how do we deploy it? Because we're not using kube control. Well, we're using YTT to wrap all of the configurations. So we're telling it, read in everything from the config directory, that's stock deployment, read in the values file, and then we have our config optional file that we want to read in as well. Use 3 cappies. And we could save this to a file like temp full.yaml. How big is it? It's that big, 14,000 lines. And then we can deploy it this way, like so. So cap, that's not, there's also a directory called deploy. So the -a is the name, we're calling it CF, and it will read everything from full.yaml. It's first creating diffs, and it's determining what does it need to deploy compared to what is on disk. And what it wants to do is update the CF API server, because we made a change to it. And we always get this little KPAC registry service account. KPAC is the technology we use to build commands on the fly. That works. I'm not going to accept it because it's not the most idiomatic way of doing this. For one thing, I have to remember to delete that temporary file. The more idiomatic way is to put the, we have our command, I'm putting time on it so we can see how long it takes. The more idiomatic way is to use a bash temporary input file to have YTT do all the interpolating there. And we're just going to say -y to say, yes, we accept the difference. And the key here is to watch what's going on in the bottom window. There, we already have created a third API server instance. It's initializing it. You can see basically CAP is running this under the hood and it's watching changes. And then we're done. So what's left is to actually attach to the Cloud Foundry instance and do something. So I still need to say skip SSL validation because I did not use a proper cert. Those were self-signed certs in the values file. And now I'm able to use, I'm able to get my password from that $values file, the values file I saved through that YQ, which is like JQ, but for YAML. And that should log us. And because I've been working here, we have an org called org and a space called space. We're there. And then we still have the ability to push an app. And the first part of this will look exactly like the Bosch-based Cloud Foundry experience, where we're just uploading the files as a package up to the API server and the blob store. And it's staging them and creating the droplet. And now we're seeing some differences, like reference to an image name with just some GUID not found. So here it's actually using KPAC to build a container based on the source code. And we didn't have to change that source code at all. It's like a standard Node app with a package.json file and JavaScript files to implement the app. Okay, actually, there is a command I like to use that shows a little more of the pods. Right, we have this workload staging. So that's where that namespace is where KPAC builds the containers. And then this CF workloads uses Irene to run the containers. And I scrolled off there, but we have the app. And I should now be able to hit it. And there it is. So just shows you how quickly you can make changes. Later on, I'll be coming back and going into a deeper dive on the technologies that I used in the command line and showed more of the pieces of CF for K8s, but it's back to Andrew now.
Thanks, Eric. So this is sort of the 30,000-foot view of the architecture. We didn't want to include a complicated architecture diagram, so this is sort of the broad overview of what you might want to care about. So you have the user-facing applications at the top, and you have the Kubernetes orchestration elements at the bottom, but you need all of this glue to stick it together. That's where all of the Cloud Foundry value comes in. You could run anything you want directly in a Docker container on Kubernetes without this layer, but you're going to lose quite a bit of nice to have functionality. So in that middle layer, you have the CF components and the open source components that we're integrating together. With the CF components, you get an API for interacting with your platform. You get authentication, authorization, you get workload scheduling, simple routing mechanics, logging aggregation, platform metrics, and app health. From the open source components, you get data persistence, package storage, secure networking, both ingress and container to container, and you get application packaging, which is quite nice. On the roadmap, because we're still actively developing this, and we have some great basic functionality, but we'd like to provide a lot more and get to parity eventually, we have our pivotal tracker. So if you want to see what's going on, what's new and being developed up to date at the moment, you can check in our pivotal tracker. It's public, so anyone can come and look and see what we're working on. So I'd encourage you all to take a look at it. We are bringing in more build pack support. So we use CNBs, Cloud Native Build Packs, to actually build these applications on the fly. So there are a number of build packs supporting different application types. The Ruby CNB recently arrived. Unfortunately, it doesn't have Rack yet, but it's still a welcome addition to be able to push Ruby apps, and we will eventually have Rack-based apps as well. We're working on Cloud Foundry acceptance test compatibility so that we can adequately test the platform and ensure stability. And there's also a Python build pack coming in as well. We have several current areas of focus. Secrets and config maps, enhancing those are our top concern. We are actively working on making, managing, updating, and rotating painless. Upgradability is another high priority. We're working on making platform upgrades as seamless as possible. This includes Kubernetes level upgrades, so upgrades to the different nodes in the API server, and upgrades to the CF for K8s specific components. And all of this is a huge concern that we want to make sure as seamless and painless as possible and provides as much uptime as possible. Image ownership is in active discussion to ensure we can guarantee a chain of custody and issue timely updates for bug fixes and security vulnerabilities, as well as any generic upgrade. I'm going to pass it back to Eric for a code base overview.
Yeah, thanks. It's more of a continuation of what I was showing before without really describing it. This is more of a description. So these are the main directories you'll see if you git clone the CF for K8s repo. Config, you can consider it like a read-only directory. It's where all of the, it contains two parts. In the second part, the YTT lib, is where all of the contributions from the external teams live in the Cloud Foundry teams. So for example, the logging, UAA, Postgres, Irene, MinIO, Cloud Controller, all of those components live in the YTT lib. The config layer, any YAML files in the config contain configuration files with like settings and secrets that you need. And as I showed in the demo, it's often better to modify them in config optional. Or you can modify config, but then of course, you're maintaining like a fork of this code, whereas config optional is where the ops files can go. Deploy is interesting. It contains Terraform, sets of Terraform scripts for 4 targets right now: Azure, Google Cloud, Minikube, Kind on GCP and Kind on Minikube, which works if your machine is big enough. Kind, of course, is running Kubernetes in Docker, K-in-D. So it's an interesting concept. it's a great area for providing, like making a contribution to the project. Say you want to deploy to another cloud that we currently aren't supporting, but Terraform does. That'd be great. Um, and then there's the build directory, which works with the vendor.yaml, and I'll be showing what vendor is in a few minutes. And we have an example of a typical build file. So after you have, say, updated, we are currently running Irene 1.0.6. If you are working on the Irene team and you'd like to test out 1.0.7, you would enter that in the vendor.yaml file, run vendor sync, and then run this build script. But I brought the build script up here not to explain exactly what it does, but to show how all these different technologies that I've been talking about work together. Helm, of course, is not part of the K14s tool set that CF for K8s uses, but these tools work well with it. So Helm emits YAML, which YTT, which is piped into YTT here in the second command. YTT reads both from standard in, that's what that -f space dash is, and you can also supply other files to modify that input. That is then written out as YAML to kbuild, which is like a Kubernetes build tool. And kbuild's at the highest level, it looks at the YAML input for references for images, and particularly images that have a SHA tag, as opposed to like a latest kind of tag for a Docker container, a Docker image, for example, because SHA images are immutable and we can count on them forever. So we can lock in a version. If you want to lock in, say, my Docker container :v3, there's nothing to stop a new version of that from getting the same tag v3, but the SHA is forever. So that's usually how we work. So kbuild, it reads in YAML, it has side effects of generating images, and then it just writes out YAML, and that's that second last line -f dash, which is writing out the output to the standard out, which is then written to our config yttlib with Irene, the render.yaml. It's going to take a minute and show you where to go for more information. K14s.io, K14s, the 14 stands for the number of letters between the K and the S. I should say number of characters between the K and the S in Kubernetes tools because it counts the space. In particular, you can learn more about YTT, kbuild, cap, which is what we use instead of kube control because it, again, is aware of the differences between the current state and the desired state. So it minimizes the amount of work you need to do. And you can learn about vendor as well. These are the 4 that we've been using today. I just want to call out with YTT that, first of all, it's a YAML-aware templating language. So that means you don't have to count spaces when you're writing YTT. You can just think in terms of the structure. You can write a function that returns a block of YAML, and you can reference that function in multiple places, and it doesn't matter where you are in the YAML indentation because it knows how to indent in the final output. It's kind of like when it renders it. So that's terrific. It's also actually built on top of a dialect of Python called Starlark. So you actually have Python definitions, and I think maybe it's possible to delete the user's disk or a lot of files because it's Python, but I don't know if it supports import system. I haven't tried that myself. But it does have a lot of power beyond a typical templating language. And then in here, you can actually play in the playground and just like select all of this and replace with your own little trial YTT and see if the result that comes out is what you're desiring, or do you get error messages. So again, that's really cool. Also in the docs, there's a like a blog post that compares YTT with other templating languages as well that I highly recommend. Okay, so Andrew will talk about PRs.
Thanks. So how to contribute, specifically PRs. PRs are encouraged. We would really like to get some community engagement on this. Welcome any interaction for discussion or anything over the direction of the project. Our goal really is to make the best tool for all users, whether you're just wanting to kick the tires or set up a production ready system. We want to hear from you. We want to make the great tools that you want to use. We have CI pipelines for checking pull requests if you would like to submit one. And those pipelines run tests. They have process gates, making sure vendors up to date, etc. The pipeline is public. So if you want to check what's running through the pipelines, or if you submit a PR and maybe it failed to check, you can find out what checks it's failed, or just get an idea of what things are actively running through in development. Our current contributions are focused on docs. So the documentation for any project can always be improved. And specifically, we would like to make our documentation pretty good. So contributing to documentation is a great way to help the community and get more involved. And especially if you have more interesting configurations that aren't well documented, you might want to help us support configurations that you think are important and useful to the community in general. So there's also a bunch of resources you can check out. So you're here because you're interested in the project, hopefully. And so if you want to continue finding out more about it, you can come visit us at the CF for K8s channel on the Cloud Foundry Slack to get involved, learn about product updates, chat with people working on the project, just keep up to date with news. You can file issues, bugs, open PRs at our GitHub repository, which is github.com/cloudfoundry/CF for K8s. The K14S tools that Eric mentioned are available at github.com/K14S. You can see YTT, CAP, KBuild, etc. And you can check out our CI pipelines by following the link on the slide. And again, those are public, so if you want to see what's going through, just go check them out. There is additional resources that are available. If you click on the little tiny URL there, that we will make sure is up to date. So thank you so much for listening. We greatly appreciate you coming and listening to us and your interest in CF for K8s, and hope you'll join us as we race towards general availability and beyond. There will be a Q&A session to follow this, where you'll be able to ask a few questions of us and we can chat and hopefully answer your most pressing questions and maybe direct you to some of our contributing projects if it is something more directed. Again, thanks. I'm Andrew Wittrock, Twitter at Andrew Wittrock, GitHub Birdrock, and with me is Eric Promislow, Twitter at Eric Promislow, GitHub Eric Promislow. So we'll see you in just a minute. Thanks.